Hello, this is Adu Muhammad, and I'm glad to introduce you to TIPD LLC and our 3-band high-energy compact laser system. TIPD LLC was founded in 2006 based on a business plan developed in consultation with the Arizona Center for Innovation. The purpose of the enterprise is to commercialize the research and technology developed by our founders' research group in the Jim Wyans College of Optical Sciences at the University of Arizona. In 2006, we have completed our first commercial sales for active polymer passive glass RF modules. From its inception to date, TIPD has developed several technologies that were acquired by large companies in the business. Our company has continued to grow through the combination of commercial sales and government contracts. In 2022, 30% of our work has been commercial work and 70% came from SBIRs and other government contracts. We have two spin-offs that came out of TIPD in 2020. One is EarDog Inc. and the second one is ICRIC Inc. TIPD's goals are to provide the warfighter with the technologies that will speed up readiness and mission success. Our technologies range from glass, fiber, and fiber laser manufacturing, fiber amplifiers, custom laser solutions, holographic optical elements, research in the magneto-optic materials, as well as machine learning and development of imaging systems that work indivisible throughout the long-wave IR. So the Navy challenges that have been presented to us is that the Navy is working into gaining deeper theoretical and experimental understanding of the maritime turbulence and laser light propagation in the boundaries, in the marine boundary. So technically, recent investigations have shown that there is a complex interaction between the turbulent structures in the ocean and the atmospheric mixing. This interaction is one of the most important factors influencing the total water vapor flux. Because of this, the Navy has asked us to develop a system that will help them into understanding what they're looking for, and then so they can use it to collect data as they wish. The current measurement technique that is being used is called the laser Doppler velocimetry, and it's also called laser Doppler anemometry. This technique has its own limitations, and its resolution is limited for long distances and cannot provide the detailed mapping that the Navy is looking for. So in response to the Navy's request, we have proposed to develop an advanced marine layer characterization source that contains 3 laser systems within one enclosure. The laser has an output of in the visible, one in the near IR, and one in the deep UV. So in response to the Navy's request, our team at TIPD have proposed the development of a 3-band pulse laser that we call the Advanced Maritime Layer Characterization Source. The outputs are going to be in the visible, near IR, and the deep UV. The separation between the chosen wavelengths is chosen such that it will allow accurate simultaneous fitting to Rayleigh and Mie scattering, which are going to provide more accurate data compared to previous techniques that have been used. And the data collected can be used to optimize and create new physics-based models that are going to be used in the future. So the current status of our system is shown here. We are able to generate 100 watts out of the 106, which is the near IR. Then we doubled it to go to the second harmonic generation. And we are working on the pulse picking, at the time of this recording, as well as we have shown our capabilities to the Navy, and they requested more compression of the pulse, which we are working on as well. As you can see on the plot here, in the x-axis is the pump, and on the y-axis is the output that we got out of the near IR. So we are able to show up to 100 watts of average power. So here we don't talk about the specifications of our laser system. So our laser system, as I said, is going to employ 3 bands, and the 3 bands are going to be in the deep UV, visible, and the near IR. And the line width, we are looking to get into few wave numbers with pulse durations that are less than 20. Right now, we already 20 picoseconds. We are already at about 1 nanosecond, but we are looking into compressing it all the way to 10 picoseconds using grading pairs. The repetition rate is going to be in the several kilohertz. That's the target, but we have already gotten close to 1 kilohertz, and the pulse energy needs to be greater than 0.9 millijoules, and the average power is going to be multiple watts. As of right now, we have already shown 100 watts in the near IR, and as we do the second harmonic and the third harmonic generation, we believe we are going to get about 10 watts output in each one of the bands. And the system is going to be ruggedized and going to be small, so they will meet the swap requirements. So the future plan is to continue working on the pulse picking until we get to reduce the repetition rate of our laser system, then characterize the chirp properties of the second harmonic generation, and build the third harmonic generation, so we will be able to get the deep UV output, optimize the chirp adjustment, and package the system as we specified earlier to meet the requirements for swap and deliver it to the Navy. For our transitioning plan, as we are going through the phase 2, we are going to do all of the demonstrations that we will be able to stretch the pulse, make it a variable from 10 picosecond to 10 nanosecond, and integrate all the subsystems together as outlined in the previous table. Then we would like to demonstrate the 10 watts as I specified earlier per each wavelength. Once the system is integrated, ruggedized together, we will deliver it to the Navy. On the other hand of transitioning this technology, as we are approaching the end of the phase 2, we will take the system to the Navy, to one of the Navy facilities, test it, show our data and all of our strategies and stuff with the stakeholder, get a feedback from them, and any kind of requirements that might have been not included. We come and then we optimize the system. Once the system is optimized, we deliver it to the Navy. Now we are done with the SBIR stuff. So the next step is to be able to commercialize the product. And in order for us to do that, we are going to use some internal funding to complete preliminary market analysis as well as a competitive analysis to DoD applications, DOE, any kind of scientific stuff, and commercial world out there. For market analysis, basically TIPD has partnered with a lot of big prime contractors such as Boeing, Lockheed Martin, and Raytheon in the past. We are still continuously working with some of them. Our current business partners include not only prime contractors, but we also have small companies, for example, ICRX, VividQ. We have agreements that we work with universities, different other research facilities, and Most of our work that we do is to just increase capabilities to the warfighter, and then our main goal is to speed up availability and make sure that capabilities increase so that the warfighter has everything they're looking for. Again, thank you very much, anybody who's listening to my talk, and I really appreciate you taking the time to really listen to us about our company as well as the technology that we are working on. And in case anybody needs more information about the system, I am Adu Muhammad, and you can reach me at the phone number listed uh, on this page, or you can send me an email. Thank you very much and have a great day.